Let's look at drawing some Lewis dot structures for some molecules that only contain single bonds. We're going to start with CH4, which is methane. So the first thing you do is write your carbon down. Carbon is over here in group 4, which means that carbon has 4 valence electrons. So put in the 4 valence electrons, right? Just like you did when you're drawing the Lewis dot structure for the atom, right? Then hydrogen, of course, hydrogen has only 1 electron. It's also in group 1. So we have 4 of them. So each of these hydrogens will come over and share its 1 electron with the valence electrons of the hydrogen, making a covalent bond. Remember, each one of these 2 electrons make up a bond. Don't ever forget that. So this is the Lewis dot structure. Once you have drawn the structure, check to see if everybody is happy. You know, they have a full octet, right? So let's look at carbon. 2, 4, 6, 8. Carbon is happy. It has 8 electrons, full octet, right? Your hydrogen. Hydrogen, remember, hydrogen only need 2 electrons because if we go over here, hydrogen is closest to helium. Remember, it's the exception to the octet rule, right? So it only needs 2. So here's your hydrogen. It has its 2 electrons. So your hydrogen is happy. The carbon is happy. This is your Lewis dot structure for CH4. That one is pretty simple. Let's do the Lewis dot structure for CH3OH, an alcohol. Again, do the same thing. Write down your carbon, and carbon has 4 valence electrons. We know that from the group, right? Now, if you look at this carbon, it has 3 hydrogens next to it. Those 3 hydrogens could only be on the carbon, right? You have oxygen. Let's go to the periodic table. Oxygen is over here in group 6, so it means that oxygen has 6 valence electrons. So you write oxygen and you write your 6 valence electrons, right? That's 2, 4, 5, 6. Now, these 3 hydrogens could be nowhere else but on the carbon. So put your 3 hydrogens in with each one of them bringing an electron with it, right? Your oxygen here, we still have this hydrogen left, which has 1 electron. These are paired up, so don't put the hydrogen where these electrons are paired up, right? So don't put the hydrogen where you have the paired up electron. You put it with the 1 electron here. 2 electron will make your covalent bond. And this is the Lewis dot structure for methanol. Let's make sure everybody has a full octet. Oxygen, 2, 4, 6, 8. Carbon, 2, 4, 6, 8. And each of your hydrogen has 2 electrons. So that's the Lewis dot structure for methanol. Let's do another one. Let's do C2H6. Now in organic, when you start having more than 1 carbon in the molecule, the carbons are generally bonded to each other, right? So in this particular structure, write your carbons next to each other, put in your valence electrons. 4, right? Still 4. We have 6 hydrogens. It's obvious that the 6 hydrogens cannot be on 1 carbon, right? Because the carbon needs only 4 bonds. So each carbon will make a bond with only 3. There's no other possible way to draw this. So if you do that, you see you have this, covalent bond. And that's the structure for C2H6. A rule of thumb, if you want to make sure that your Lewis structure is correct, you want to double check, right? Just check to see if the total number of valence electrons that you have in the molecule, we're going to use this as your example, is in your Lewis structure. So for example, Carbon has 4 valence electrons. We know that from the group it's in. Then you have 4 hydrogens, so it's plus 4 for the 4 hydrogens plus 6. And this is equal to 14. Let's see if we have 14 valence electrons in our lowest dot structure. 2, 4, 6, 8, 10, 12, 14. So yeah, that's it. You have covered the 14 valence electrons in the molecule. Everybody in the structure is happy with their complete valence. And this is how you would draw the structure for the Lewis dot structure for some of the organic molecules you'll run into with single bonds.